Good morning, good morning. Happy Wednesday. We're going to start today on page 36, so if you can open to page 36. And while you do, we'll have our daily look at the calendar. So I've highlighted the next few classes. Last class we talked about taking the derivative of ln, and we talked about the derivative of arcsine and arctangent. Today we're going to kind of wrap up our derivatives section. We've been doing a lot of different derivative rules over the past few weeks. We're going to bring them all together today and do some really complicated derivative problems. On Friday we have a quiz, which is on the 3 classes, including this one and the previous 2. And on Monday, project number 5 is due. Project 5 is just like naked practice of well, that's not how you should practice your derivatives, but like it's not even couched in other terms. It is just like brute, here's some derivative problems, practice with them. And they're quite complex, and I'm hoping that the stuff we do today will help you better be able to deal with the complicated derivatives for that project. So that project, again, is due on Monday. And then Wednesday, 1 week from today, what's happening? Somebody help me with the days here. So that's Friday, Monday. So on Monday, when the project is due, is our review day for the test. And then the test is Wednesday, 1 week from today. Any questions on the calendar? I got that right, didn't I? Today, Friday, Monday, Wednesday. Yeah, the test is everything below test number 1, so it is kind of chunked off. That said, I feel comfortable asking you to do the new stuff, but still apply it to old stuff. So it's not, there won't be anything specifically testing the things on the first test, but you know, math is a cumulative subject, so I still expect you to be able to do those things, but the test is basically on what's in between these 2 tests. Other questions? All right, and one last announcement before we jump in. We are right around the middle of the semester, and there is always a danger at this time of the semester for students to start to kind of feel overwhelmed or lose motivation. So if you feel like you are slumping, maybe a course isn't going as well as you'd like, maybe different, not this one, but another course isn't going well, maybe none of your courses are going well, there are resources, and this afternoon at noon today, a couple of folks here on campus are going to talk about solving the problem of the mid-semester slump. So, so it's happening today. It's in the core 208. There is free pizza, but also good problem-solving strategies. So check it out if you have any interest. It's not only for people who feel like they could be doing better. If you feel like you're on the ball and everything is going great, go share your strategies for success. All right. I mean, it really is just this open forum. So check it out if you're interested. Okay, so again on page 36, right here way at the bottom, it says today is all about practicing with our new derivative formulas to find derivatives of complex functions. Before you start, let's have a quick look at the strategy guide below. So the strategy guide starts on the next page, and I will tell you that this strategy guide is the same as the thing on the first page of the packet. So you'll rip it off the first page when it comes test time, but we'll use this one right here. Okay, and so just very briefly, here in the table is a list of all of the, or most of the derivative formulas that we have seen. You have your power rules, first one, e to the x, a to the x, sine, cosine, tangent, ln, and arctan and arcsine. Those last 3 we covered last class. And then there's this really important thing that says, if a function doesn't look exactly like one of the things in the table, then you need another technique. So you guys can handle e to the x using this thing in the table, but you can't handle something as simple as e to the 2x using the table, all right? So if it's in the table exactly as you see it, perfect. If not, we got to use something else. And so down here is a list of the something else's. And so if you have a sum or a difference, that was the first day of derivative stuff where we said, oh, it's nice. You can just separate them and find 2 different derivatives and add up the derivative answers. Tells you what to look for, tells you what to do. Constant multiples, we've seen them a million times. Product rule, quotient rule. There are some cautions here, something like, you know, cosine of 3x is not a product rule. It looks like multiplication, but we know it's not. That's a composition. Quotient rule, and then finally the mother of all derivative rules down here is the chain rule. I've written it in a couple of different forms. Tells you what to look for, all right? So I'd encourage you to look at this thing today as you're, maybe as you're working on these derivative problems throughout this class. familiarize yourself with this sheet. I really think it's well written, and I'm not complimenting myself. I took this from a predecessor, Curtis. I think it's really well written, but have a look at it at some point. And then on the next page has examples. So for this first one, first and foremost, it is the sum of two functions that are simpler. And so we'll split this thing up in our minds and use this idea of the sum rule. And those two simpler functions are both in the big table that we just looked at on the previous page. This thing right here, you could use the product rule. I've seen some people use the product rule for 3x to the fifth. You'll get it right, but you're going to spend some extra time doing it. Why do we not need to use the product rule? But what is true about that 3 sitting up there? Is a constant. Use the product rule when it's function with x times function with x. That 3 is a constant multiple. It just sits there in the front. What rule is that one? That's a product rule. Two things with x in it. How about this one down here? That's quotient rule. Another product rule. What is sine of x to the fifth? Nikki? What'd you say? That's right. And what rule did Nikki apply there? That's a chain rule, right? There's a complicated function inside of sine. This thing right here looks quite similar to the previous one, and it is also a chain rule, but it's a different chain rule, and the derivatives are different, so we got to be clear on those. And then here we get to more complicated things. First and foremost, what rule is that? That's a quotient. And in the midst of doing the quotient, we see how complicated the denominator is, and what rule is that one? Product rule. But you just follow the quotient rule. It tells you step by step what to do, and at some point you'll have to find the derivative of the bottom, and then you say, oh shoot, that's another rule. It's a product rule. First and foremost, what's that? That's a product, two functions multiplied. And then in the midst of doing our product rule, I see that. What rule is that? That's chain rule. Something complicated inside of sine. How about right here? What rule is that first and foremost? So this one has kind of a different answer for me. I mean, yeah, it's a chain rule, right? This is ln of some stuff. So that's a chain rule. And in the midst of doing the chain rule, what rule do we need to apply to the derivative of the stuff? Product rule. Okay. So again, I think this is really well done. Again, kudos to Curtis for putting it together. Let's do a few of these problems as a class, and then you guys are just going to work your tails off in your groups finding derivatives of complex functions. Okay, first one. F of t equals 100 e to the negative 0.1 t sine of pi t plus 200 e to the negative 0.1 t. All right. First thing I'm going to do, even before I write equals, what am I going to write? F prime. Need to use notation, can't have stuff floating around. You need to tell me I am taking a derivative right here. Okay, first and foremost, actually let's jump to this guy. Well, even before we jump to that guy, the first thing that I see here is a plus sign in the middle. The plus signs make you happy or sad when you see them in calculus. They make you happy because the plus sign rule just says separate them and add the derivative separately. So that's the first thing I see, and I'll go ahead and jump to the second term. This one seems less complicated than the first term, so I'm just going to copy my plus sign. I'll put it way out here just because I'll need some space for the first one. And then we'll take a derivative of this 200 e to the negative 0.1 t. Product rule? No need. What do we do with the 200? We keep it. Constant multiple stay. 200 times. Now I have e to some stuff. The derivative of e to some stuff is e to the stuff times derivative of the stuff. So we copy the e to the stuff. And then we multiply by, maybe I'll put this part in green because this is our chain rule, multiplied by the derivative of the stuff. What is the derivative of this thing up here in green? Is a negative 0.1. Okay, let's jump back to that first one then. Any questions on the second one? That one's done. If you want to simplify, you should multiply 200 by negative 0.1, negative 20. That's it. And then for the first one, what rule do I need to use up here? Is it a product rule? No, this is just 100 times. So what happens with the 100? It stays 100 times. And then we have e to some stuff. Well, we just saw this. So what's the derivative of e to some stuff? Is e to the stuff times the derivative of the stuff. Actually, I feel like I need even more room than I left myself here, so let's move. Okay, so we are now here. All right, so I'm going to highlight again in green. We did the e to the stuff, and now we have to multiply by the derivative of that stuff. What rule is it that we're going to take for the derivative of that stuff? That's a product rule, because I see t times something else with t times sine with t. So in here is going to be a big old product rule. So we're looking at the product rule of just that highlighted green stuff. You can separate these two things in a couple of different ways, but the way that I will separate it is I will call it negative 0.1t my first function and sine of pi t my second function. Product rule has a first and a second. Okay, so the product rule says first times derivative of the second. So we copy the first times. Now we need to multiply by the derivative of the second thing that's circled there in blue. Sine of pi t. What rule is that? Sine of pi t is not in the chart. It's not in the basic chart. It's the chain rule. It's sine of stuff. Right? Sine of pi t is sine of some stuff. So what's the derivative of sine of stuff? It's cosine of that stuff. So we go cosine of pi t times, and then we're looking at the derivative of the stuff, different stuff than before. That thing right there. What's the derivative of pi times t? Is pi. Okay, I think we're almost done. That was half of the product rule that we were in the middle of. It's really easy to get lost because the rules kind of tend to telescope out, like they just kind of branch out. It's easy to forget where you were in the big picture. So in English, what we just did was first times derivative of the second. Now we do the rest. Plus second. So we're going to copy that second term, sine pi t, times the derivative of the first. What's the derivative of the first circled thing? Negative 0.1. Nikki. Mm-hmm. Yes, this whole thing here, I'll put in big red brackets. This whole thing is the derivative of the stuff. So it is all multiplied by this e to the negative 0.1t. Other questions on that one? Tiffany? Good question. So first, there isn't a whole lot I think we can do. I mentioned we're going to multiply these two guys together and just call it negative 20 e to the thing. And over here, I don't know. I don't see much of anything. I mean, like there's a negative 0.1 there and a negative 0.1 there, which could both get factored out to the front, and then maybe get shoved in here with the 100. So multiply those guys together. I don't really see much else, if anything, that we can do. Not a lot. Okay, let's try part B. Z equals W arc sine of W over W squared minus 4. So the first thing I want to do before I think about even what the derivative is or what rule to apply is write some notation. So can you guys write some notation that symbolizes derivative? It's no longer f prime. You got to use the letters Z and or W. Okay, so one way to write this would be z with a what? The prime, so that's the derivative. Or if you didn't write it in the Leibniz way, can you write it in the Leibniz way now just to refresh our memories? Good. So we know the Leibniz way is normally dy dx. In this case, the letters change to z and w. Equals.
What's the thing when they just write d over dx?
That is like writing this. You know this symbol means take the square root of whatever you see next. Yep. And so this means take the derivative of whatever you see next. Yes, so yeah, so we'll change the x to a w in this case. So d dw of z. Yeah, it makes sense that the z goes on top. Yeah, good. Okay, so now let's think about the actual derivative rule. So which rule is this first and foremost? It's a quotient rule. Quotient rule for me, I always start with the bottom because there's potential to get lost in doing everything upstairs that you forget there is a downstairs. The first thing I write is the bottom squared. Okay, and it's important that we get this part right because the order for the quotient rule matters. Does the quotient rule start by copying the top or copying the bottom? It's the bottom. So we go bottom, w squared minus 4 times the derivative of the top. And now I see that the top is actually kind of complicated too. What rule is that up there? That is a product. W's times W's. Okay, so let's do the product rule. So product rule upstairs, first times derivative of the second. First times derivative of arc sine of W. Fortunately, that's one of the few functions that's in our basic table. It's okay if you don't remember it. You're going to have it with you on the test. I don't think I'm going to provide it on the quiz coming up, so write it on an index card if you don't have it committed to memory. But what's the derivative of arc sine of W? Minus W squared. Yep, change that X to a W. What's that? That times that. Okay, so that's first times derivative of the second. And the product rule, is it plus or minus? That's plus in the product rule. We're in the product rule part right now. Plus second, so we'll copy the second. Times the derivative of the first. What's the derivative of the first? 1. First one is just the W sitting in front. This derivative is 1. What did we just finish? That was the product rule, which was the derivative of the top. So now we come back, zoom out. We're still doing the quotient rule. We did bottom times derivative of the top. The quotient rule, is it a plus or minus? Minus. And then we do top times derivative of the bottom. So we'll copy the top. Times the derivative of the bottom, 2w. It's almost a letdown how easy the end of that one was. In terms of simplifying, don't. I mean, like I'll tell you when I want you to simplify. I mean, the fact is that really the only kinds of derivative problems that are readily simplifiable are pretty straightforward derivative problems. And so I want you to be able to handle these complicated derivative problems, but the trade-off is that there's nothing to do in terms of simplifying. They're so messy that there's anywhere to go from there. So don't worry so much about simplifying. It's really just about putting together all of these rules to find one complicated derivative. Okay, questions on that one? I have a question. Is the font too big? I made them bigger because there are so many symbols, but is it is it laughably big on the paper? No? Okay. All right, let's try part C. Yeah, that's why I did it, because yeah, they can get pretty small when you have several superscripts. Okay, g of x equals square root of 2 to the x ln of x. Great. So, again, good notation, g prime of x. Okay, so what I'd like you guys to do is go back 2 pages. Remember the chart with basic derivatives at the top? Little chart at the top of the page, 2 pages before this one. And we're going to try to identify, it's this one up here. We're going to try to identify which one of these rules is the basic one that applies, even though it's complicated. But we have a square root of 2 raised to the x ln of x. Can you guys figure out which one is the basic one that applies? Yeah, it's this one right here. Because we have a to the x means a number to the x. We have a number to the lots of x's. So our basic rule is that one, a to the x times ln of a. So let's see if we can apply that basic rule here. So this reminds me of a to the x, and the derivative for that one we know is a to the x ln of a. Okay, so normally it should be you copy the a to the x. So what are we copying? Whole thing, square root of 2 to the x ln x. What comes next? Good, times ln of square root of 2. That's not the chain rule, that's just part of the basic a to the x rule. A to the x rule always sticks on that ln of a. But then we have to say, wait a minute, it wasn't just root 2 to the x, it was root 2 to something complicated. So the chain rule is going to come in and say multiply by the derivative of that stuff that's highlighted in green. What rule do we use for the stuff highlighted in green? Product rule. So let's try. First times derivative of the second. First is x times, what's the derivative of ln x? It's in the chart. It's 1 over x. First times derivative of the second. Product rule says then plus second, copy ln of x, times derivative of the first, 1. Yeah, so this is really just ln of x, and actually the first one simplifies to 1. So this thing is the same as this. Questions on that one? All right, let's take a look at the last one here. Y equals e to the cosine of ln of x squared plus 1. Every time I say of, that's another chain rule. So this is going to be multiple chain rules because of the nesting inside, inside, inside. All right, so again, good notation. Can you guys write it with the prime and also with the Leibniz, just for practice? So if we're doing the prime, what letter goes underneath it? Y. If we're doing Leibniz, dy dx. Okay, first and foremost, this is e to the stuff. So the derivative of e to the stuff is e to the stuff. Times, and then we're going to do the derivative of the stuff. So I'll highlight here in green again. We're looking for the derivative of all this. So whatever that is going to go in here. So I see cosine of some stuff. So that's another chain rule. So the derivative of cosine of stuff is negative sine of stuff. Yeah, be careful with those negatives. So negative sine of the stuff times, and then we got to do the derivative of the new stuff, which is this part. Okay, this is ln of x squared plus 1. I need the derivative of that. That's ln of some stuff. Other chain rule, the last chain rule. So the derivative of ln of stuff, 1 over. So we do 1 over the stuff, which is x squared plus 1, times, and then finally, yeah, we need the derivative of the newest stuff, which I'll highlight here in blue. Derivative of x squared plus 1, 2x. I think that's it. Questions on that one? Joe? Hmm? Okay, so here's the plan for the rest of the class. The homework assignment is on the next page, and it basically just says we're doing 1 to 73 odd in the complex derivatives section. The page number is given in the packet. So let's spend the next 45 or so minutes just doing these homework problems. I'm going to walk around and answer questions, but I'd encourage you to at least partner up and try to work on the same types of problems with your partner. You don't need to start at number 1 and do every odd in order. If you feel like you've got a handle on the first few problems, move on to the next kind of problem, right? It's more important to do a wide variety of problems than to do 1 to 20 and then run out of time and never see 20 to 70, okay? So we've got the rest of the period to just practice this kind of thing. Again, it's quite similar to these are similar to the problems I'll ask you to do on the project. So lots of practice, and we should be prepared for the project too. On the quiz as well, we'll see stuff like this. Friday, yeah.
Then I don't remember for working on the project. Do you think it was good?